And hello, everybody. Today, this lecture is actually not a lecture. I wanted to go over the answer key for our homeworks. And so I'm going to start bite-sized chunks. We're going to go over each homework individually. So the idea from this is grab your answer key, grab the homework, grab your answer key, and then follow along. Some of you did remarkably well. Other folks, again, I have to ask everybody, please do the reading. Watch the videos, watch the lectures, read all the way through. I've had a host of people that they are looking at the homeworks first and then searching back. That doesn't work well. And the reason that doesn't work well is there's a lot in the reading, there's a lot in the videos, there's a lot in the learning material that I just can't assess. I can't test you on it all. When I'm assessing and testing you on are either some of the key parts, or I just have to randomly pick a few to test. I can't test you on everything that's in there. The idea is if you're able to do this without looking back at the notes and get 70–80% of it right, you did a good job by absorbing the material. If you're only learning what's on the homework, if you're only learning what's on the assessment tools, quizzes, what have you, you didn't learn enough. I've had a handful of folks that it really, really looks like you're looking at the homework and Googling the answers. I had one person where the mucin layer, where is it secreted? They said the respiratory tract. Guys, that yes, there's mucin in the lungs. That's not what we're talking about. Please don't Google the answers. It's not the right way to do it. And could you pass a class potentially? Yes, but you're just not learning. The idea is please go through the learning materials, read the articles, read the required readings, and then look at the homework. And if you need to, look at the homework again and just go through the required reading and required materials, and then see what the final answer is for those of the questions that you may have missed, or just to verify that they're correct. Many of the homework questions are almost verbatim out of the learning materials. If you don't see it there and it doesn't really click at you, you probably may have the wrong answer. So please, I gotta stress this. I've seen this from a handful of students. Most of you are doing well, but I'm seeing patterns from some folks that give me some really goofy, creative answers. And in the past, if there was even a rationale that I could okay it because that's correct, yeah, fine. From this semester and these homeworks, if you didn't get it from the reading material, the learning material, and it's not what I was looking for, I'm not giving the benefit of the doubt anymore, because it means you weren't looking at what we asked you to look at. Now, today what we're going to do, homework 1. So I'm going to share my screen. We're going to go through every single one and show you what I was looking for. So I want you to go over every single one of your homeworks. Let's get this bigger. Again, you have a grade. Most of us have the grade. Some of us, I've asked you to resubmit because the formatting is wrong. Another thing, if I ask a single document in either Word or PDF, please don't hand me 7 JPEGs. I'm just, at this point, I'm not going to accept them. It's been very clear on how I've asked to do things. And in the past, I've hated to be a stickler. But when we get into practice, when we get into entering RXs at work, when we do compliance, when we do billing, if you don't do it how you're supposed to, you get in trouble. If you're not following directions properly, that's part of what this program is about. And to be honest with you, part of getting a degree isn't that you learned everything, it's that you're able to go through the hoops of applying, registering for classes, applying for financial aid, going through the hoops. There's a benefit to that as well. There's a learning process that shows you can do something that other people may not have had to go through. So again, please, 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 if I say to submit it on a Word or PDF document, don't give me photos. If I say to do a single one, please don't give me 7 documents. You're just going to get dinged on it. I may not even accept it going forward. And if you have trouble, go to the library, and they have a lot of resources and tutoring for you to get the help you need. You can look it up online how to do it. You can look at the library sources. Please, please, please follow the directions. Now, sharing the screen, layers of cornea in order from anterior to interior, from the outside to the inside. This should be absolutely unequivocally know it, know it, know it. NCLE is going to have it in multiple questions on corneal anatomy. It's very, very important. And in this, it's the epithelium is always on the outside. The endothelium is always on the inside. Stroma is the big one in the middle. If you know those 3 right there, 60% of the whole thing is done. And I always would say the Descemet is the basement layer for the bottom of the cornea, the inside of the cornea. So that would be next to the endo. So essentially, it's epithelium is first, The epithelium would be there. Bowman's would be next. Then you have the large 90% of the stroma. You have the decimase layer, which is the basement layer for the endo. And then you have the single layer endothelium. And remember, this is a single layer that does a pumping mechanism. It keeps the eye essentially dehydrated enough to keep it clear. If it doesn't work, you're going to get swelling of the eye, you're going to get cloudiness of the eye, you're going to get edema of the eye. You don't regenerate endothelium cells, whatever you have, upon adult development. You simply, if you lose them over time, the endothelium starts to change. And remember, we got into things like polymegathism, pleomorphism. Look those up if you don't remember, but those are all endothelium, and that's the inside most. So epi is A, endo is E, and it goes in order from there. And again, which layer makes up the approximately 90% of the structure's entire thickness? This is the collagen fibers that are aligned the right way. This is the most structure of the eye. There's a number of ways they could ask this question on an NCLE type question, but number 2, the answer is the stroma. The eyelid muscle responsible for opening the upper lid is levator superioris, superioris. I just call it the levator, but if you have the entire name, the 3-word name, I'm okay with that too. And that's what lifts it up. And it takes the top lid, you only have one on the top, and it sort of lifts it up. If you squint, that's for question number 4. The muscle in the eyelid, that is a sphincter muscle, and you have them in your heart, you have them in your body, you have them in different areas. I'm sorry, in the digestive tract, in your eye, anything that is in a ring type thing and it squeezes to come shut, that, in this case, the muscle, and you have one in your iris too, it expands, it dilates, and it shrinks. You have mydriasis, you have meiosis. So the sphincter muscle that squeezes in your iris is also a sphincter muscle. But in this case, what I'm looking for is the muscle in the eyelids, and that's the orbicularis oculi. According to the book Reading, Chapter 2, the term for a dense opacity of the cornea is called the, that's not a term I use too often, but it was in the book, and I'm always, a lot of these books that you see that are written from the CLSA or the National Academy of Opticianry, oftentimes they're going to use definitions that they try, that some of these people are the same people that wrote the tests. And so in this case, I was looking for leukoma, L-U-K-O-M-A, leukoma. And if you start seeing different, you can break the words up and see the suffix and the prefix and figure those all out. This is the following, number 6 is a picture. The following is a relatively common ring-like lipid deposit in the peripheral cornea. It generally affects those in an older population. Again, from the reading, this is right out of there, and you can Google this image, you can look at it. And again, we have some folks of certain nationalities and ethnicities that have this more than others. It comes on with age, and this is called Arcus senilis. Absolutely benign. It's not a disease. It's not dry eye. It is just a little bit of a lipid deposit. It's thought that a lot of folks who have this may have higher blood levels of lipid, like higher triglycerides, higher incidence of heart issues, cardiovascular issues, up in the air. But in this case, this is 360 degree off to the periphery. If you put fluorescein on that to look at the epithelium, it is intact. And what gives it away is the common ring-like lipid deposit, peripheral cornea, generally affects the older population. I got some curious numbers on this. I got corneal disease and dry eye disease, and dry eye disease has nothing to do with lipid deposits in the cornea. So again, this is just a finding that you would see, relatively common. Make sure they're being seen by their doctors, but it's not going to affect what we do for contacts. And that's what a lot of this anatomy is for. If you see something unusual, is it a problem? Or is it just interesting? This is interesting, but it's not going to affect our ability to wear contact lenses. There's no infection, there's no inflammation. This is just a little deposit that you simply see, and it's easier to see with dark eyes because you can see the background. The glands of Wolfram and Krauss, number 7, Wolfram and Krauss are types of accessory lacrimal glands. What do we have? What do lacrimal glands produce? Well, remember 3 layers of the tear layer. The outside is the lipid, the inside is the aqueous, the bottom layer that's up against the closest to the eye is the mucin layer. Your lipid is made by the meibomian glands. The aqueous is made by the lacrimal and accessory lacrimal glands. And the inside, the mucin, is made by the goblet cells, which are on the inside of your palpebral conjunctiva, in the goblet cells on the conjunctiva. In this case, what I'm looking for is the glands of Wilfring and Krauss. I gave it to you, are both types of accessory lacrimal glands. What do they secrete or produce? It's the aqueous portion of the tear layer. Make sure you know all three of those. And actually, we bring it up in room 9 again anyway. The inside of the eyelid is called the palpebral conjunctiva, while the conjunctiva over the globe is called the bulbar. Where they meet is, well, if you look at this here on my eye and I flip my lid, you can actually see the inside of my eyelid. That's my palpebral conjunctiva. You can look at that. If you look at the top of my eye, there's the bulbar. Well, the palpebral conjunctiva and the bulbar conjunctiva go all the way in the back. Well, they meet towards the top of the eye. You can't get a contact lens stuck behind by your optic nerve. They would get stuck in this little cul-de-sac up there, where this here, there's a part where it ends. Sometimes you'll get contact lenses shoved up there and stuck. You read news articles about a person who had in their cul-de-sac or in their fornix, they get debris, they get contact lenses stuck up there for a long time, and we can fish them out. It's unusual, but where the palpebral conjunctiva on the inside of my eyelid and the top of my eye, the bulbar conjunctiva, where they go in the back and they meet, that's called the cul-de-sac or the fornix, and that's what we were looking for. If you go back to our first line and look up a video, what do you call let me see if I can. If we look at the side, this is essentially a cross section of a person's eye right here. And if we did a cross section, stop it. There we go. I'm going to get a better video right there. This is the inside of the eyelid. This is the bulbar conjunctiva, and when they meet right here, that's called the fornix. There's a superior conjunctival fornix, and there's an inferior conjunctival fornix. Where the eyelid and the conjunctiva over the bulbar of the globe, and the conjunctiva that lines the inside of the eyelid, where they meet, is called the fornix. Please remember that. Next one, name each layers of the precorneal tear film, anterior to posterior, front to back. Front is the part that keeps it from evaporating. The front is your lipid. The next is the aqueous. The inside is your mucin layer. And please read the question, for the love of goodness. I can't believe how many people miss this. And where they are secreted or produced. If you looked, I believe, on the question, there was a little crosshatch, because I was showing you there's two different answers, one / the other. Outside is lipid, inside is aqueous, middle is aqueous, inside is mucin, and they are produced by, in order, the outside lipid is produced by meibomian glands, and those have the little, they're in the lid into the tarsal plate. You can actually see the little openings where they're secreted. Then you have the aqueous, which are the accessory and the lacrimal and the accessory lacrimal glands. And then finally you have the mucin is by the goblet cells, and the goblet cells are in the generally palpebral conjunctiva, but we just say the conjunctiva, and that's good. Put the following structures in the right order in which a tear film is drained from the eye. They go into the puncta, top and bottom. They travel down the inferior canalicula, the top and the bottom. They get into the lacrimal sac, and then finally down the nasolacrimal duct, in order. You can look that up in a picture. We had it in, and what's really cool is, imagine if you had dry eye. Sometimes it's the quality of the tear, sometimes it's the quantity of the tear, but if they're produced and drained, one of the ways you can keep more tear on someone's eye is you can put a plug right in that little puncta. And if you plug it up, they're called punctal plugs. All the tears that are produced are kept on the eye longer, so it will alleviate some people's dry eye conditions and complaints. If you understand what this anatomy looks like, you'll know why it happens. If we put fluorescein dye in someone's eye, when we're doing contact lenses, when we do slit lamp, as your tears are produced and as it irrigates that out and it drains through the puncta and goes down through the rest of the area, it drains into your nose. So if you blow your nose later on, you have bright yellow liquid, or when you cry, your nose runs as well because you have a lot of liquid going down, it drains into that area. 11, a non-infected blockage of a meibomian gland is called, guys, you got to know this one. Some people, like doctors, and when we were kids, anytime you had a bump of any type, we always just called them a sty interchangeably. Non-infected is a key word. In the meibomian gland, it's just like, almost like a pimple. If you block it up and it doesn't drain, it accumulates that meibum, that lipid layer, and it blows up like a little balloon almost, and it's called a chalazion, or properly it's a chalazion, but I've always said chalazion. Either way, I don't care the pronunciation, but it's C-H-A-L-A-Z-I-O-N, chalazion, if you pronounce it properly. The biggest one that I'm looking for is that's not infected. It's not red, it's not tender, it doesn't hurt. If it gets infected, if there's an infected blockage of the eye, we generally call that a hordeolum. Non-infected chalazion, infected hordeolum. Hordeolums, when they're infected, that's what a lot of people refer to as styes. I'd prefer you use hordeolum versus chalazion. And the chalazion can be different glands that are blocked up and infected. The hordeolums, rather, are ones that can be blocked up, and you can have front, you can have back, you can have but again, the biggest one that you'll ever see is just look at non-infected versus infected for my purposes. Chalazion, blockage non-infected, hordeolum, more of an infection of the gland. So 11, I was looking for chalazion. 12 and 13, I'm really disappointed in this one from a lot of folks. Again, right from the reading. 12 is an inward turning of the eyelids. 13, an inward turning of the eyelashes. Those are two different things. In some cases, you have the eyelids that are intact, but the lashes are growing the wrong way. And in other cases, you have the actual eyelids flopping in or turning in. Eyelids versus eyelashes, two different concerns, two different issues. An inward turning of the eyelids is called entropion. If the eyelids turn in, it's an entropion. Now, are the lashes scratching the back of your eye? Are they scratching the front of your eye? Are they in contact? Sure, but the major issue is the eyelids are turned in altogether. Ectropion is when they're floppy and they turn out and the palpebral conjunctiva is exposed. 13 is an inward turning of the eyelashes, a misdirection. The lids are fine. They're the right way, but the eyelashes are growing the wrong way. They're poking into the eye. And if it's just the eyelashes, that's called trichiasis. There's a couple other conditions. I'll have you look them up. There's dystichiasis, two layers of eyelashes. There's a couple of those, but in this case, 12 was entropion, 13 was trichiasis. Please, again, right from the reading. Some diseases of the eye, such as a stroke or Bell's palsy, cause an inability for the eye to close, which can lead to significant discomfort, dryness, damage to the eyes, even scarring. This incomplete eyelid closure is called lagophthalmos. We see this a lot. Bell's palsy is just a paralysis of one's face, but with no underlying causes. People who have a stroke, they can have the same thing, but it was caused by a cerebrovascular accident. But that lagophthalmos is what I was looking for. Image below. When a small amount of blood is trapped between the conj and the sclera, it can produce from trauma, violent cough, Valsalva maneuvers, heavy bowel movement, lifting something, blood thinners. There's a number of things where if you get a little bit of and if you ever looked at when you're a kid and you're in science for 7th or 8th grade, where you had the slide where you put the plate and a little drop of water, and you put the slide cover on, it just whoop, it expands really quickly. Most of these here are actually a very small amount of blood. They just look scary as all get out. It's more prominent folks that are taking blood thinners, diabetics, and other systemic issues. It is often painless and can only be noticed when looking in the mirror. This condition is called, and this is a subconjunctival hemorrhage. You have a little bit of blood that leaked out between the sclera and the conj. We see these all the time. They generally absorb. If somebody has heart issues or clotting issues, we worry about it. But this is not, I have eye pain, I'm not having inflammation, I'm not having photophobia. And these are pretty common. Anytime you see anything unusual, please refer out to a doctor just to be safe. We don't want you to be the last person to say it's fine, but this is generally innocuous and generally not an issue. And again, trauma, small amount of blood trapped between the conjunctiva and the sclera. I mean, this is right here, and it's pathognomonic for a subconj heme. The image below, area that is caused by UV exposure and irritation. This little area, this little bumpiness, I saw a lot that said photokeratitis. Photokeratitis, this is a photokeratitis if you're out in the sun too much, or if you have exposure to welding, you can get burns on your cornea. Keratitis is an inflammation of the cornea, and you would have a overall, like if we put fluorescein for photokeratitis or any type of keratitis, the cornea is inflamed, the epithelium is beat up, it stains with sodium fluorescein, which will show a green dye that we use. This eye is very quiet. This is not an angry eye. This is just a little bump that over a long period of time, again, they grew up in the equator. They took a lot of time outdoors. It's just a long-term buildup of this little bumpiness. Often, and generally, it can be on both sides. It's more often in the nasal, but it can be on both sides. And this is called a pinguicula. And again, it's UV exposure, a little bit of irritation over time. People spend time in cooks, like countries where they cook indoors and there's a lot more smoke. People who smoke more. UV damage. These people, if you just worn sunglasses from the time you were a kid, you wouldn't have any of these. But these don't visit and don't encroach on the cornea. When this decides to grow over, it's the same. Actually, if you think about it, I would argue that there's a little bit of a overlap where at some point when it passes the limbus and it starts going in this little triangle area, this is called a pterygium. Starts with a P, P-T-R, pterygium, like pterodactyl. But this is a very common. I would be shocked out of my mind if you guys don't see questions like this, pinguicula or pterygium, on exams like an NCLE, and these are pretty common for naming claims, if you will. 17, what are the 6 extraocular muscles that are responsibility? I should have asked you how they work, what their primary mechanisms are. I didn't. It's just the 4 recti: inferior, superior, medial, lateral, up, down, left, right. And it's got the 2 obliques, inferior and superior oblique. This was not a difficult question. It was just, again, name and claim. I do want you to be familiar with the motions, but what causes adduction for reading? Those are the 2 medial recti. I could tell you what's up, down, left, my left, my right, and you should be able to tell me what the primary mechanisms are for those, and what the agonists are and what the antagonists are. What makes it move in that direction, and then what muscle has to relax to let it move in that direction so it doesn't pull back. This is important. Cornea maintains its clarity by maintaining a state of deturgescence or dehydration. Which layer of the cornea is primarily responsible for the pumping action to keep the cornea clear? We covered this earlier. It's the endothelium. As people age, there are certain diseases, and one of them is called Fuchs, F-U-C-H apostrophe S, Fuchs endothelial dystrophy, and that's when you start losing endothelial cells and they can't keep up with the pumping, and the eye starts to get cloudy because it just can't do its job. In the question above, when the cornea is not able to maintain a state of deturgescence, if it's not maintaining its pumping action, if it's not keeping dehydrated and keeping clear, it gets cloudy, it retains fluid, it doesn't look. That's called corneal edema. List of the following definitions. This one, it was pretty straightforward. Again, I wanted you to read the material, and the top is keratitis, any inflammation of the cornea. Generally, it gets all beat up. There could be different areas, there could be different reasons. It could be infectious, it could be inflammatory, it could be photokeratitis, like we mentioned before, but the cornea itself is all angry, mad, inflamed, and that's what keratitis is. Corneal neovascularization is neovascularization anywhere is growth of blood vessels where you don't want it. Diabetics can have it on their iris, in the back of their eye for the retina, but we're talking about corneal neovascularization. So it's simply new blood vessel growth in an area that it's not supposed to be there. The cornea is supposed to be avascular. There are no blood vessels running all throughout the clear cornea. It would not work well. They don't, the primary function of the cornea, of the blood vessels, oftentimes are to get, one of the primary focuses is to get oxygen to that particular body part. Your eye, your cornea, the cornea itself, doesn't need blood vessels to get oxygen to it. It gets it from the ambient atmosphere, diffused from the atmosphere through the tears to the cornea. If you don't give it enough oxygen, though, as a side effect, as a response, the eye will actually create blood vessels to burrow into the cornea to try to get at the oxygen that it so desperately needs. That is a bad complication if you're sick or if you have poorly fit contacts. Ulcer, loss of corneal tissue. It can be injury, inflammation, infection, but the idea is it's a loss of, it could be a crater, it could be, but the loss of corneal tissue is what I was looking for. And again, I asked specifically from the reading, these were just definitions you could type right out. And the last, the infiltrates are a group of white accumulation in the cornea. And this, we actually sometimes have little white areas in the cornea from hypoxia. And a lot of people say, oh my goodness, it's an ulcer. It's oftentimes not an ulcer. They're just sterile peripheral infiltrates, little gray areas off to the cornea, off to the side of the periphery of the cornea that may indicate an upcoming problem, but it's not as bad as, say, a corneal ulcer. Cornea provides approximately how much of the total refractive power of the eye? 43 diopters was fine, 70% was fine. Either way, just know that you're always going to get questions on what is the primary focusing part of the eye. Cornea is always there. And then second, obviously, is the crystalline lens. This layer cornea makes up 10% of the corneal thickness. I didn't like the question, except it was right out of the reading. 90% is the stroma. The epithelium is 5 to 7 layers. That's about 10%. And remember, the endo is only 1 layer, so it's even thinner than that. It's less than 10%. So 90 for stroma, just about 10%, and the other ones are so small that they almost don't make up they make up a negligible amount percentage-wise. So I was looking for 23 epithelium. The vertical measurement of, get this, the palpebral fissure of the average eye is, and that is not the horizontal, not how up and down my iris is or how wide, the horizontal visible iris diameter is how much from limbus to limbus, 14, 15 millimeters on average. Didn't ask that. The palpebral fissure is the opening between the top and the bottom lid. And if you take a look at my eye, part of the top iris is generally covered, sometimes part of the bottom. It's generally got to be less than that 14 or 15. In the book, I got 10 millimeters. 10 was fine. 11 I gave you credit for. Anything outside of that, 14 or 15, is absolutely wrong, unless you have somebody who's got very droopy eyelids or they're very surprised all the time. But from the reading, again, the average vertical measurement of the palpebra for the average eye is, we're looking for 10 millimeters. The main source of oxygen for the anterior structure of the eyes, meaning what is the main source of oxygen for the cornea? It's not blood vessels. It's nothing off to the limbus. It is diffused oxygen from the atmosphere that goes through the tears. Any combination or anything like that was good. I got stuff from vessels. I got something from limbus. I got something from aqueous humor. Remember, the aqueous humor is behind the endothelium on the inside of the eyeball. I took off more points for this because this is a gimme. You have to, this is the basis of everything we do. The main source of oxygen, please know it, please live it. You'll see it repeatedly. If you get that wrong, hell, you get this wrong too late in the class, I'm just going to have to take tons of class. It's just too much of a gimme. You have to know this one. Where are the goblet cells located? Technically, the conjunctiva was okay, but I'm looking for specifically from the reading, and I was pretty liberal in giving you guys credit for this, but the goblet cells are what produce mucin, which anchor the tears to the corneal surface. And those are created, the goblet cells are located generally in the superior palpebral conjunctiva, but conj is fine. It almost didn't matter, but I was looking which part of the conjunctiva was better. sorry, I missed 26. A dense opacity of the cornea is, if you recognize this one, I did it twice accidentally. It's glaucoma again. We had this earlier in, I just wasn't paying attention. So you got double credit for this one if you're doing your reading. Transitions between the bulbar conjunctiva, that's the white part of my eye with the conjunctiva over it, and the cornea, that's the circle that goes around my cornea. That we were looking for the limbus. I got a lot of confusion between limbus and fornix. Pay attention, look, you got to read carefully. Between the conjunctiva and the cornea, this little, where do they meet? That round circle is called, excuse me, the limbus. Fovea centralis contains primarily which type of the photoreceptors? Fovea, macula, central, sharp vision, color vision. Cones is all I was looking for. You have very few cones outside of the central part of your eye. Very central is mostly cones, and then it slowly dissipates, so you don't have as many, but then you start getting your rods, and about 20 degrees from fixation is where your peak rod location is, and even as you get farther and farther out to the periphery, you get fewer and fewer photoreceptors of any kind. Even rods get fewer. That was from last year. So periphery, more rods. Centrally, more cones. And remember, cones are color, detailed vision, that type of thing. Photopic vision, which means during the light. Scotopic vision is darkness, and those are what rods are for. Rods are for dark movement, low vision, low light situations, that type. So the fovea centralis contains primarily which type of photoreceptors? It's either cones or rods. I was looking for cones. Bony orbit, I had all sorts of stuff. Pyramid is fine. Cone is fine. Again, I just want to make sure that if you look, it's wide open on the inside and it goes back into a point. There's a lot of answers for this, but just wanted to make sure you knew how it looked to accommodate the eye and all the extraocular muscles. Pupil constricts. Dilate is big, not dilate. Dilate, two syllables, D-I-L-A-T-E. So if you go in to a doctor to have them look at your eyes, when they shine light in your eyes, the pupil constricts. That's miosis. We don't want it to shrink. We need to look in there. So the doctor will put drops in and the pupil dilates. Those are called mydriatic glasses, or the glasses we have are post-mydriatic specs. Those are the little sunglasses the doctor gives you because you'll be light sensitive, because when you go out on a bright sunny day and the doctor dilated your eyes to look into the side of your eyes when they're trying to shine bright lights in, they had to put those drops in. The drops still work 2-3 hours afterwards. If you go outside on a bright sunny day, your pupil can't shut the light out, so they give you little sunglasses. Those are post-mydriatic specs. So dilate, getting bigger, mydriasis. Constricting, getting smaller, miosis, please. The agent that is responsible for bactericidal in the portion of the precorneal tear film, again from the reading, guys, lysozyme is specifically what we're looking for. It goes around like a little sentinel and kills all the bad stuff. And if it's working properly, you have enough of it. It's not just that the epithelium takes everything off, it's that you have stuff floating around your tears that plays seek and destroy to all the bad stuff that could cause an eye infection. Major function of the middle tunic or layer of your eyes. Globe itself has 3 levels. The outer the outer is your protective tunic. That's your sclera and your cornea. The inside is the vascular tunic, and that allows and brings cools down the retina, brings nourishment and good stuff to the retina, blood supply to the back part of the retina. And then the inside is a neural tunic, and that is your the retina itself, macula, fovea, retina, etc. What we were looking for as a main function of the middle tunic was essentially nourishing the retina, and that's essentially what we're looking for there. Let's see. A loss of vision caused by damage to the nerve fibers of the retina, often caused by increased intraocular pressure. Your eye is supposed to maintain a certain amount of pressure. Your ciliary processes on the ciliary body, they produce aqueous behind the iris. It fills up and it continues to make, it keeps the eye at a certain level of pressure. It goes through the front of your, inside your eye, through your pupil, and then comes back down into your anterior chamber, and then it drains in a place called the trabecular meshwork. So there's always fluid inside your eyeball being produced and drained, and it should keep a certain amount of pressure at all times. For some folks, or for certain reasons, you get an increase in intraocular pressure, an increase in the pressure inside your eye, too much liquid produced, too little drained. And that pressure will build up and damage all of your photoreceptors. It damages your rods, it damages your cones. And that, remember, you don't have as many photoreceptors off to the edge. So as they die off, you start losing your peripheral vision first, and that's called glaucoma. They can do surgeries or drops to lower the pressures. But again, you're losing the nerve fibers of the retina, you're losing the photoreceptors, and the increase in pressure, it's called glaucoma. Different types, we can get into that later, but this again from the reading. All the colors we see are generally produced by how many different photopigments? You got 3 photoreceptors primarily. Most people have 3 color cone photoreceptors, and we talked about those. So the answer for this is there are 3 different photopigments. Now, being verified and being activated in different concentrations will allow us to see or process that different colors are supposed to look different, but it's only 3 different photopigments. There is one small genetic variation where there's a handful, like I don't know what it is, but exceptionally rare where somebody may have a 4th photoreceptor. It's the exception rather than the rule. The rule is most of the colors we see are generally produced by 3 different photoreceptors. Transposing. Guys, this is basic stuff from your other class as well. Here you have the sphere, the sill, the axis. The sphere, -3. Sill, -275. Axis 0.5. To transpose, it's like putting on a lens cross from your other class. You have a -3, axis 5, and 90 degrees away, you have the full sill, the full sphere, plus the sill, 90 degrees away. So if you put it on a lens cross, you can go back and forth, or you can just transpose it using our rule, and that is add the sphere and sill algebraically. So a -3 and a -275 together are a -575. Change the sign of the sill, so it would be -575 plus 275, and then change this by 90. Well, 90 degrees away from 5 is 95. Same thing with this. When we start doing eighths, because we run in eighths, and remember, when I'm doing eighths, it should look like 1/8, 1/4, 1/2, 3/8, 1/2, 5/8, 3/4, and 7/8. Or you can even say 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. It's the same thing. We just simplify the quarter, half, and we don't call them eighths. We just call them quarters and halves. In this case, it is 1/8 is 0.125, but we write this as 0.125, or we refer to as 0.12. This is an eighth. We're really dealing with 125, but for our purposes, optical notation, we'd put 1.12. This is a quarter. This is 0.375, which is 0.37, but we ignore the 5, which is 0.37 is how we write it. 1/2 is 0.5, easy. This 0.625 or 0.62 with a 5 in parentheses because we're going to drop it, or 0.62. My 0.62 is not 0.62. It's shorthand for 5/8. 3/4 is 0.75. And I'll put these all in the same area, 0.37, 0.5, 0.75, and the last one would be 0.875 because you're going up by 0.125 every time, so 0.875, and it's 0.87 with the 5 understood, or 0.87 is all we're looking for. When I'm asking you to transpose or write in eighths, you must give the answers in these notations here, 0.12, 0.25, 0.37, 0.5. I don't have very many things I ask you to remember. This is one of the few things that I need you to do this every time. And this is important because the minus 612 and 375, when I transpose this, add the two algebraically, and it's minus 9.87. Minus 612 and minus 375 is minus 9.87 plus 375, and 90 degrees away from this is 179. Pretty easy. Well, here are my answers for all those. And the one thing I want to point out to you is for the answers, and I'll post these. The next one is plus 325 minus so here are the answers on each one. We'll put them side by side for you to see. I'm sorry, I don't have a mouse. I have to do the stupid keypad. So plus 325 minus 125x is 40. Transposes 2 plus 3 1/4 minus 1, and add that to a minus 175 is the same as 325 minus 125. So it's a plus 2. Change the sign, add 90 to it, plus 2, plus 125, axis 130. The next one, plus 525 plus 250, add the two algebraically. What's a 525 and a 250? Plus 525 and a plus 250. It's a plus 775. Change the sign of the second number, 90 degrees away. Plus 775 minus 250, axis 100. You should be able to do each and every one of these for the axes in your head accurately. Remember, math, you don't have to be Stephen Hawking for math here, but you do have to have some math skills here. Otherwise, the curriculum gets a little tough. If you're having trouble with math, we do have tutoring services through the college. Plus 425 and a minus 5. If you combine them, it is a minus 75. Change the sign, and then change this by 90 degrees. Minus 0.75, plus 5, axis 165. And this is what threw some folks here. What's a minus 825 and a plus 62? When you combine them, it ends up being a minus 463. But back to what I said before, there is no such thing as a 463 when we're talking. You have to know and understand that 4 and 5/8 has to be written as minus 4.62 minus 3.62 axis 75. That's one of those that you just have to understand. And I did take off a half a point for those who gave me 4.63 because that's incorrect. And then the final ones, most people did really well on this. However, there were a few little mix-ups and mostly in the orientation. Put it on a lens cross. This is a minus 3 in one meridian and a minus 575 in the other. They're both minus. It is compound myopic astigmatism. Great. Let's just go through the orientation. Minus 675, minus 325. It's minus 612 in one. It's minus 987 in the other. They're both minus, compound myopic. Plus 325 and a plus 2 in the other, because again, you add them to do algebraically. So I have a 325 in one meridian, a plus 2 in the other. They're both plus, compound hyperopic. Plus 525 in one meridian, a plus 775 in the other meridian. If you put it on a lens cross or transpose it, both are plus, compound hyperopic. Plus 425 in one meridian, minus 75 in the other meridian. Mixed astigmatism. One's hyperopic, one's myopic in the two different major meridians of a lens. And the final is minus 825. But in the other one, it's minus 462. Even though this number is plus, if you plot it on a lens cross, or if you transpose it, it's a minus in both meridians, compound myopic astigmatism. Most people did really well on this. It was the axis that was terrible. Remember, the easiest way to think about it at 180 plus or minus 30 is with the rule in minus CIL. So if we look at this, minus CIL, it's axis 5, it's right near 180 with the rule. Minus 375, axis 89, almost 90. If you're close to 90 in minus CIL, within 30 degrees, it is against the rule. If you are not within those two and you're closer to 4 or 5, if you're not within 30 degrees of 180, if you're not 30 degrees within 90, everything else is oblique. Well, this one's a pretty close one. It's easy. 45, well, that's oblique. But this one, it's axis 10, and you would almost think it's with the rule. But it's not, because this is in plus sil. I have to transpose it. And when I transposed it, it was axis 100. 90 away from 10 is 100. If I'm within 30 degrees of 90, it's against the rule. Well, 100 degrees transposed into minus sil is well within 30 degrees of 90, so it is against the rule. This one's already a minus sil. I'm 75, which is only 15 degrees away from 90. If I'm within 30 degrees of 90, it's against the rule. Against the rule. And then finally, this has to be transposed again. So, because it's in plus sil, so make sure when you're doing against the rule with the rule, change this to minus sil. This in minus sil is 75, which is again the same one as this. It's within 30 degrees of 90 degrees against the rule. So these are the answers. I'll post these explanations. This was the video. Go through it, because a lot of your quizzes that will be due, that will be timed. Don't care that it's open book. If you don't understand how to do it, you're going to run out of time. Study this, go through your homeworks. If you got too low, I'm willing to have you redo the homework, resubmit it, and I will average the grades out or find some way to give you extra credit. My job is not to make you do poorly. And there'll be a limit to that. If the max I would bring you up to is probably an 80 or so. I'll have to determine what the number is. But if you got a low grade, if you do this over again, I will be able to improve your grade to some point if you put the effort in and learn the material. So thank you guys. I appreciate everything. And I'll post this, and I can't wait to see you guys pretty soon. And I'll continue to do this for homework. So not only do you have the homework and you have the feedback for the grades that we're going to put up, I'm not even interested in the grades so much as I am to understand the material. And by going through this video, you'll get a better idea. And we'll put up a quiz, a timed quiz, but it'll be on these, any materials fair game, but more so potentially make sure you're understand the concepts here, because some of them I may ask you ectropion instead of entropion. I may ask different layers of the tear film. There's a lot I could do. So just keep apprised of the situation. I appreciate it. And as always, give me a holler if you have any questions, and I'll talk to you again soon.